So thank you. First of all, I would like to thank all the organizer of the conference. I think it's a really cool conference. The spirit is really like we are a little family. It's really kind. So I have here 10 minutes to talk about some softwares I'm editing and publishing on GitHub. Sorry for that. So it's entirely written in Python. Some of them are using C types. So that's for my colleagues. It's mostly libraries targeting telecommunication systems. So everything is available on GitHub. So the first library is called Card. It's done in order to communicate with mostly SIM and USIM cards, so the SIM cards that you have in your phones. So basically, it's putting nice function names on APDUs that are transmitted to the SIM card. So you can read the whole SIM. There are also some nice functions that can be used, like for example, to brute force the file system of the SIM card and check if you have any special, like proprietary files on your SIM with access control that you have to grant to access the content and so on. There are also scripts to personalize, like blank SIM cards that you can buy from the Sysmocom shop, which is a shop in Germany run by the people making the Osmocom project. The second library is called Cryptomobile. It's the one using C types, because there are some C implementation of the cryptographic algorithm which are used in mobile networks, so basically in 3G and 4G networks. And they are wrapped into Python in order to be called easily into the rest of the library. And so there are 3 different algorithms in Python. There is also the CMAC mode of operation for IES, which is implemented on top of PyCrypto. There is also the MyLineage algorithm, which is implemented. It's the authentication algorithm, which is used between the HLR or HSS in the mobile network operator and your SIM or USIM card within your phone. So this library is of really good use if you have to work with mobile network protocols. The third one, which is actually the biggest library, it's a bit like also a trash library, because I put everything that I don't know where to put. I put it into libmish. That's because of this. That's the name of the presentation. Basically, in the beginning, it was inspired from Scapy, but I had to deal with network protocol that were not like stacked, like IP protocol with a header and payloads. And so I implemented a lot of mobile telecommunication-oriented protocol, like the second bullet, it's listing GTP protocol, layer like LabDM, which is for GSM. Then you have the radio resource control, mobility management, call control, SMS, session, SS is for supplementary services, GPRS mobility management, and so on. There is also the UICC secure channel if you want to talk with a SIM card, which is using the secure channel protocol. You have also little implementation. So it's only decoders and encoders which are provided here for IEEE protocols. Some files format are also supported, like some picture files and image and video. So running those protocols was not enough in order to really interoperate and interwork with telecommunication networks. Within those networks, you have plenty of protocols which are specified with ASN1 syntax. So I implemented actually a teeny ASN1 compiler within the library, and BER and PER codecs. The second one, it supports aligned and unaligned encoding. So PER is bit by bit, and the unaligned says that everything is packed bit by bit. And aligned one says that sometimes you put some bits of padding, but sometimes not. And you have lots of protocols, like the RRC are the protocols that are run by all your mobiles to connect to a base station in 3G and 4G. Then you have other kind of protocols like RANAP on S1AP, X2AP, which are used between base station and core network in mobile networks. You have like also PCAP, LPP, which are protocols for localization management into mobile network. And finally, there are some support for MAP, which is used between mobile core networks, between operators and so on. And there is an ongoing support for TCAP, but it's not really working yet. There are also other kind of stuff feeding this library, like diffie-Hellman, CRC, some pseudo-random function from the NIST and so on. There is also some funny function like the string for shifting string. It's really useful, actually. I'm using it a lot. Finally, within this garbage collecting library, I've put some extended function, like some function to run an MME, which is part of an LTE core network. There is also an HSS-like for generating authentication data for USIM cards. There is something which handles user traffic, which is encapsulated within the GTP protocol inside mobile network. There is also an SMS handler, which is maybe not committed yet, but will be committed soon. And everything together, actually, it powers a newly, it's actually not a library this time, it's a complete application, which is an LTE core network in a single Python script. It's called Cornet. So it's actually what you see on the right side with the Cornet name. So it's driving LTE base station. So you need eNodeBs, LTE base station. So it's not something you can buy easily. Maybe you can go to Alibaba and find some. And then you need LTE terminals and USIM that you can customize, actually personalize. And then you have a running LTE network. And from the core network, which is what I like, is that everything is running within IPython. So I have actually an interpreter which allows me to dynamically change every parameters of the core network and access and interact with the handset which is connecting through the base station. So basically that's it. Thank you for your attention. Just would like to thank also my employer for allowing me to release all this open source stuff, and also a call here because I have few people which are requesting me stuff by email, but I have not much contribution or extension proposal. Some few experience report. And what is also cool is to get captures or pickup from real network in order to implement better decoders and encoders. Okay, thank you all.